Starting with this first problem, always first thing you look for is, are there any common factors you can remove? And from this first problem, there's no common factors, but what you should recognize is each of these terms are perfect cubes. And if you think of what value are you cubing to get 125x cubed? 5x. And what value are you cubing to get positive 27? 3. Again, a plus 3, a positive 3. And so this fits that pattern of the sum or difference of cubes. The factoring pattern for that is you're going to have two factors, a binomial and a trinomial. The binomial is just going to be the sum of the bases that you're cubing to get your expression. So we take the base 5x and the base positive 3, and we just add those together. That's the binomial factor. Okay, to find the trinomial factor, I break it down by term. The first term is just the square of this first expression, or the first base. So square the 5, square the x. Our last term is going to be the square of the second base, or the second term of the first binomial. So if we square positive 3, we get positive 9. Okay, now the middle term is the tricky one. It's the one that is the product of these two bases with the opposite sign. Okay, it's the opposite of their product. So 5x times 3 is positive 15x. We change the sign and we get our factors. Okay, so this would be your factored form for that first problem. Is that your question? So you're kind of asking what if it was, and I'll just use a simple example, x cubed minus, let's say 64. If this was your set, what you would get is, this is the base x cubed and the base negative 4 cubed. So you'd first take the sum of those terms, x and a minus 4. And then you take the first term and square it, x squared. You take the second base or term and square it. Negative 4 squared is plus 16. And the middle term would be the opposite of this product. X times negative 4, that is your negative 4x. But since you changed the sign, it would become a plus 4x. All right, let's go ahead and move to the right here. We'll do this problem next because it's a really quick problem, but it's also one that a number of you probably missed. The first step on any of these factoring problems is to remove a common factor first, right? So what common factor can you remove from these two terms? When we remove a 4, take that out. 4x squared divided by 4 leaves x squared. And positive 36 divided by 4 leaves plus 9. Okay, so now you're left with the sum of two squares. And do we have a pattern for factoring the sum of two squares? We have the difference of squares. If that had been x squared minus 9, we have a factor pattern. Sum of squares are irreducible. They can't be factored any further. Okay, so a number of students probably had x plus 3 quantity squared, right? Remember, you have to account for that outer plus inner product, which would have been the plus 6x. And since that's missing, you can't say this is x plus 3 squared. And you just leave it. This is as far as it can go. The only thing that can be factored out of this is a 4. All right, the final problem down here is trinomial with a coefficient of something other than 1. So you remember you have those two options. We can do trial and error and reverse FOIL it, or we can rewrite the middle term. I'm going to show you both. Okay, the first term is not a prime number, the leading coefficient. So, like, again, to me, I would probably use that to tell me I'm going to go ahead and rewrite the middle term to start with. But you can do either. If you are going to use trial and error, what we need to look at is all the possible factor forms when you FOIL that give you this expression. So the first terms that yield 6x squared are 6x and x, or 3x and 2x. So really, we only have the two possible combinations here. Now, the last term is, the product of the last terms is positive 5. Since the outer and inner sum is negative, we know that these signs have to be negative, so that helps us. That eliminates half of any possible combinations we need to test. And when we look for the only products, or the only two factors that can give us a product of 5, are negative 5 and negative 1, or negative 1 and negative 5. We have to account for each order, and that's going to be true for each of these possible pairings. So negative 5 and negative 1, negative 1 and negative 5. So really, we only have these 4 combinations to test. So when I'm looking at this, if I test these using the outer and inner products, I have my here at the top, I have a minus 6x minus 5x giving me negative 11x. That does not work. I can eliminate that. Here I have a minus 30x minus 1x does not give me 17x, so I can eliminate those. And down here, when I apply my outer and inner, I get minus 3x minus 10x does not give me negative 17x, so that's not it either. And I do want to confirm this. Minus 15x minus 2x does give me my minus 17x. So it wound up being my last example, but I only had to test 4 combinations, so it's not really all that bad. So 3x minus 1 times 2x minus 5 would be my answer. And now, like I said, if I was doing this, once I see that my leading coefficient and constant aren't both prime numbers, I would probably be tempted just to go straight to the rewrite the middle term method. And that method involves the following. I would take the product of my leading coefficient, my constant. 6 times a positive 5 is positive 30, so I'm going to write that right here. And then I would look for 2 factors of positive 30 whose sum is that middle term's coefficient. So what 2 numbers can you multiply to get positive 30 and add together to get negative 17? Negative 15 and negative 2. So if I rewrite my middle term as that sum, negative 15x minus 2x, which is still negative 17x, drop down my first and last terms and factor by grouping. In my first pair of terms here, what common factor can I remove? A 3x, leaving 2x minus 5. In my second pair of terms, there's nothing you can remove, right? There's no common factors, so just take out the sign. My sign is negative. Whether it's positive or negative, I would physically write the 1 here. Because again, if you do it this way, the one error that tends to be encountered is to leave out the 1 and then not really know what to do with your second binomial. So write the minus 1. So we're taking out the negative sign. This becomes a positive 2x. And again, it changes signs, becomes a minus 5. If you've done this right, you should have a common binomial, 2x minus 5. I'm going to take that common binomial factor out, and the remaining factors of 3x and minus 1 form the terms of my other binomial factor. And as you can see right here, it doesn't matter which one, which method you use, you get the same answer. The order of those factors doesn't matter.